Hello, everybody. Thanks for joining us today. My name is Gavin Phillips. Thanks for joining us for the session, AI-based insights transforms radiology workflows. Let me grab the clicker here. Again, my name is Gavin Phillips. I'm the worldwide partner leader at AWS, covering life sciences, partner solutions. I've been at AWS about 3 years, based in Charlotte, North Carolina. So thanks for joining today. I'll pass it over to Brian to introduce himself.
Hi, everyone. My name is Brian Warwick. I'm a principal solutions architect for healthcare and life sciences, based out of Houston. Been with AWS more than 5 years now. And Gavin and I get to work with some really amazing partners that are doing a lot of awesome stuff in the healthcare and life sciences space. So thanks for hanging out with us at the right before replay, and a lot of fun we're going to have tonight. But we're going to talk about radiology here.
Thanks, Brian. So like Brian said, our team specifically focused on industry solutions with partners. And today we're going to dive deep in how we're seeing the healthcare and life sciences space use generative AI, specifically within medical imaging and radiology. So just to kind of give you a flavor of what we're going to cover over the next 20 minutes or so, we're going to share a little bit about what some of the challenges that we're seeing with the medical imaging space. We're also going to walk through what a typical radiology workflow would look like. Then we're going to look at some partner solutions that were specifically built for the industry, leveraging AWS native services, et cetera. And then we'll wrap up with some next steps and what you can do to learn more. So let's jump in. So these probably look like some pretty consistent challenges, regardless of what industry you may practice in. But for us today, we're going to specifically dive into what does this look like from a medical imaging lens. When you think about file sizes, file types, it really depends from an imaging perspective. There's lots of different modalities, right? You could have MRI imaging, ultrasound, PET scan, so on and so forth, and each have their own complexities and challenges that come with it. And with those, they have their own challenges around storage and transmission and how to process that data at scale. And so that's what we're working with a lot of our partners on to solve for some of those challenges. Just as an example, like a typical CT study, it would contain anywhere from tens to hundreds, or even I would say an average is about like 1,000 slices per image. So if you think about imaging of an organ or something like that, and 1,000 individual image slices, if you just took 1 second to look at each image slice, that'd be over 16 minutes. So you can kind of think about the challenge that radiologists deal with each and every day when they're trying to evaluate such a massive amount of data. And that's just looking at the images. You're not even talking about insights, you're not even talking about summarizing, or all the ancillary activities that go around to support that radiologist in their workflow. So why radiology of the things that we could talk about in healthcare and life sciences? What's really interesting, as of August this year, the FDA has a list of AI, ML-enabled medical devices. And at that time, it was totaled up to, I think it was 950 total devices. And what this slide shows is a visual representation of all those devices that were AI, ML enabled. 76% of those fell into the radiology and medical imaging category. And there's a lot of different reasons for that. And that's kind of staggering, especially when you look at some of these other categories like cardiovascular, neurology, and so on. And I think what we're seeing in the industry is that there's lots of startups working within the space. There's lots of large corporations working within the space. And there's just a lot of innovation happening from a technology perspective. What we're also seeing is that, from a radiology perspective, it's typically one of the biggest value drivers within the health system. And on top of that, it also carries significant clinical value for patients. And so when you kind of have those three combinations of technology innovation, business value within a hospital organization, and then patient and clinical value, that's really a recipe for a lot of transformation within a given sector. And I think that's why we're seeing so much growth within the radiology space, and that's why we at AWS are working with partners and building specific services to help them innovate on behalf of their customers. So we talked a little bit about the device industry. Let's take a look at what do clinicians think about AI/ML? Like where do they want to go for the next steps utilizing this technology? And this is actually a survey from the American Medical Association. And the big takeaway here is on the far left, right? You see 56% of the clinicians suggest that administrative burdens and tasks are really the biggest opportunity to have automation within the clinical space. And really, radiology is not necessarily different. If we kind of look at this same information from a radiology lens, a radiologist is going to want to see things like, hey, the right order has been created, or they have the right set of views to do proper analysis for a given patient, given their condition. Even the angles at which you're taking these images is extremely important, and if a radiologist doesn't have the right views, they can't provide the right feedback and the right summaries to downstream specialists and clinicians. And then lastly, they need the right kind of artifacts for them to draw overall conclusions for patients and ultimately improve patient care in that process. And we'll touch a little bit on that on the next slide. So what we're going to walk through here is a build out of what a typical radiology workflow looks like. It starts with a physician ordering a scan for a patient. Depending on the condition of that patient, there's going to be a specific modality, whether it's CT, MRI, ultrasound, PET scan, what have you. And typically those orders are saved in the electronic medical record platform or a radiology information system. Now once the scan takes place with the patient, then it's moved over for storage, and it's typically called a PACS system for healthcare providers, right? There's lots of opportunities around translating that from the device to storage. There's a lot of edge computing and AI/ML opportunities there. And then once the image has been moved to storage, now we got to talk about imaging. If you're a radiologist and wanting to start to look through these images, and in many cases, like we mentioned earlier, tens if not thousands of images, those typically get pulled down from the PACS system. Sometimes they have a viewer built into it. Sometimes there's a separate viewing station that these radiologists work from. And they're not only looking at the image, but they also need more context, right? They're pulling in information from the electronic medical record platform, maybe patient labs, looking at their comorbidities and other challenges that they may have from a health perspective. And that's a really difficult challenge for radiologists when you're thinking about all these different data inputs while evaluating all these different images. It presents a challenge. And after all of that, they need to create a summary of what their findings are, right? And when they're doing these impressions and they're wanting to look at, okay, what's the differential diagnosis? What are the leading indicators of what they're finding in their imaging that is actually going to impact downstream patient care? Once those reports are finished, they get pushed out to either the PACS system or respective electronic medical record platform. And so today what we're seeing is a lot of innovation, and some of the partner examples that we'll talk through is really taking place in this green oval down here around that report generation. And there's lots of opportunity for generative AI to evaluate images, pull in ancillary data from electronic medical record platforms, and really support that process to create a cohesive summary for either downstream specialists or in patients themselves, so they can kind of understand what they're looking at. So these are a few different categories that are represented in the last slide that we walked through. Not all of them are represented there, but these are just a list of use cases that are specific to radiology. And the team that Brian and I am on really works backward from those use cases. Those use cases represent customer challenges in the industry. And so when we're working with partners, we're wanting to identify solutions and capabilities that they have that deliver against use cases like this, specifically within the imaging setting. And we do that similarly across all of our other industries. We've got a booth right over here if you'd like to learn more about that. But on the healthcare and life sciences side, we do the same thing for payers, providers, life sciences, pharma, et cetera. And so this is kind of the approach that we take as an industry partner team to work backwards from the customer. And so with that, I'm going to pass it over to Brian to actually walk through what that process looks like in action.
Yeah, so when I'm working with healthcare and life sciences companies, the number one thing that we always first start with is security. And you always hear this all the time from AWS, that security is job zero. So we now at AWS have more than 164 high-trust certified services that healthcare and life sciences companies can go build with. So in the HCLS space, high trust is a way to essentially get certified and prove that your solution meets those requirements that healthcare and life sciences organizations expect in order to deliver care. Now, out of those 164 high-trust certified services in the radiology space, and in particular in the healthcare and life sciences space, we have 4 services depending on the data modality that you're dealing with. Okay, so we have Amazon Health Lake for clinical data. We have Healthomics for genomic data, Health Scribe for audio data, and what we're going to be talking about today is health imaging for DICOM and imaging data to store that on AWS. Now, the other important thing is, Gavin was talking about you want to use that data for AI/ML. And so it's critical to understand that everything we do at AWS with security designed from the ground up, we don't train models based on anyone's data. It is your data. And we create this platform where you can go bring your data and build models and use those 164 high-trust certified services to go build your solutions. And so that's what Gavin and I do in the partner side of AWS in the healthcare and life sciences space. Now, we have a lot of partner solutions out there that are doing some really awesome stuff. We had time to pick 3. And what I like about these examples is all of them were built on Amazon Bedrock. So Bedrock, I'm sure everybody's heard about that here by now. You get to pick and build with whatever large language model makes sense for your specific use case. Now, this first example is from a company called Smart Reporting out of Germany. And what's really interesting about this use case is they built a product that creates these sort of what they call impressions of the images of all the various scans. What I find really interesting about this is they built this entire product strictly through prompt engineering. They leveraged Bedrock out of the box. They worked on a prompt that made sense based on their data, and they were able to bring this to production in rapid time. So when you think about Bedrock, you can either, and if you're doing AI/ML on AWS and working with large language models, you have a variety of options from prompt engineering to something else. You may have heard of a thing called RAG, where you can start to kind of bring your data into that model. This is another example. This is a partner called Dataless. So they're an electronic health record company. I work with a lot of different EHRs here at AWS. And Gavin talked earlier about that whole flow, where it's not just about the image, but it's also about the clinical data and pulling all of that together. I don't know, has anybody here worked, I worked at a hospital before AWS. I don't know if there are any healthcare people out here. Has anyone seen like the radiologist workflow? And they're in a dark room looking at a screen, and they don't want to necessarily have to jump back and forth between screens and try to get access to the data that they need. So what's really cool about what Dataless built here is, if you see, there's a reference architecture on the right, but they used RAG with clinical data from the EHR and the image to essentially embed this AI assistant right into the radiologist's workflow. So this allows the radiologist to really ask questions about who they're looking at, and really get better insights into the patient, as opposed to having to sort of jump around all different places for information and really try to deal with that. There's just thousands of data points, as Gavin mentioned earlier. So another really cool example of what we've seen some partner do this year in the imaging space. Now, I mentioned you could do prompt engineering, you can do RAG, or on AWS, you can also go and build your own LLM from the ground up. And in this next example, Hopper actually did that. So they went out, they took all of their medical images, and they went out and they built their own model from the ground up on AWS. So what I find really cool about this is they can actually ask questions about the image itself. So this, these various partner solutions, from simple prompt engineering to building all the way on the ground, from the ground up, I think really highlights what you can do on AWS and get started relatively easily, because all these solutions launched this year. So really exciting to see what partners are doing in this space. Now, I've talked about a couple different AWS services. So AWS Health Imaging, if you want to store DICOM on AWS, we have a link here if you want to go learn more about it. I talked a lot about Bedrock as well. We have a link here if you want to go learn more. I would also encourage you to go look online, similar with health imaging. Go take a look at Health Lake. If you're dealing with clinical data, it is a great AWS service for storing data from the electronic health records in AWS. And we also encourage you to go take a look at our generative AI partner playbook. I think this was just updated. Take a scan of it. But we have a whole guide about how you can go to market, how you can build and grow with generative AI on AWS. And then, as mentioned, this has just been updated. And this is available to all partners in our GenAI Center of Excellence in Partners Central. So I think we have like 2 minutes. I don't know if anyone has any questions or anything. But if you are part of, do we have any AWS partners here? Yes? Yeah? Okay. So shameless plug about Gavin and I. We're here to help. We have teams of people that, like Gavin comes from the industry, I come from the industry, and please reach out to us. We want to make sure that, whatever challenge you guys might be running into, we're here to help you unblock and get that to market. So I want to thank you all for your time today. I know it's been a long day at reInvent. Hopefully everyone's going to be able to make it out to replay tonight. And hope you all had a fantastic time at reInvent this year. So thank you all for coming out, and nice to meet you all again.